Let's move on to question 11. This question tests your understanding of the properties and the monotonicity of the absolute value function. The problem asks us to consider the function y equals the absolute value of x. Let us visualize the graph. It forms a classic V-shaped centered at the origin. For any x is less than 0, the line goes down from left to right, means that it is a decreasing function. However, for any x is greater than 0, the function simplifies to y equals x, which has a positive slope, making it an increasing function. Therefore, the correct conclusion is option B. When x is greater than 0, the function is an increasing function. Question 12. The focus here is solving a rational inequality and identifying domain restrictions. We need to find the solution set. To solve this, we treat it like a quadrant inequality. The roots are -1/2 and +1. Because the inequality is less than or equal to, the valid interval is between these two roots. However, a denominator can never be 0. In interval notation, the correct answer is A. Question 13. This question tests the formula for the arithmetic mean and basic operation with square roots. The arithmetic mean is simply the sum of the two numbers divided by 2. Let's calculate 2 minus the square root of 3 plus 2 plus the square root of 3 divided by 2. The negative and positive square roots of 3 cancel out perfectly, leaving us with 2 plus 2, which is 4. Then 4 divided by 2 is 2. The correct answer is B. Moving to question 14. This problem focuses on finding the slope of a line given two coordinate points. The line passes through point A, -2, 3, and positive B, 3, 1. Let's recall the slope formula. Slope equals y sub 2 means y sub 1 over x sub 2 means x sub 1. Plugging in our numbers, the slope is -2/5. The correct answer is C. Question 15. This question tests your ability to define trigonometric radius using a point on the coordinate plane. Let alpha be an angle containing the point P, 1, 3, to find the sine of alpha. We need to find the distance from origin, R. It equals the square root of 1 squared plus 3 squared, which gives us the square root of 10. The definition of sine is the y-coordinate divided by r. We must multiply the top and bottom by the square root of 10, resulting in 3 times the square root of 10 over 10. The correct answer is B. Let's look at question 16. The focus here is to identify the defining characteristic of an arithmetic sequence. Remember, an arithmetic sequence must have a strictly constant difference between consecutive terms. Let's test them. Sequence 1. The difference is constantly positive 6. So this is arithmetic. Sequence 2. The difference are 2, 3, and 4, not constant, so it's out. Sequence 3. The difference is constantly negative 2. This is arithmetic. Sequence 4. The difference are 2, 4, 8, not constant, so it's out. The correct answer is A. Question 17. This problem directly tests the distance formula between 2 points on a plan. The formula is the square root of the sum of the squared difference of the x and y coordinates. Let's calculate carefully. For x, -5 means 3 is -8. Squaring that gives 16/4. For y, -1 means -2 is +1. Squaring that gives 1. Adding them together, 16/4 plus 1 is 16/5. Finally, we must take the square root, giving us the square root of 16/5. The correct answer is B. Now for question 18. The focus here is connecting the angle to the slope and then finding the linear equation. A straight line has an angle of 45 degrees. The fundamental rule is that the slope m equals the tangent of the angle of indication. So m is exactly 1. The line passes through the point 0, 2. Because x-coordinate is 0, this point is actually our y-intercept, b. So our slope is 1 and our y-intercept is 2. Using the slope interaction from y equals mx plus b, we simply write y equals x plus 2. The correct answer is B. Question 19. This question tests your algebraic skill in completing the square to find the center and the radius of a cycle. The general equation given is x squared plus y. Squared means 4. X means 3 squared equals 0. Let's group the equation. X means 2 squared plus y squared equals 7. From this standard form, the center is 2, 0, and the radius squared is 7, means the radius is the square root of 7. The correct answer is C. Question 20. We are given that sine of alpha is 4/5 and alpha is in the second quadrant. In the second quadrant, the sine function is positive, but the cosine function must be negative. So cosine alpha is the square root of 1 means 16 over 25, which is the square root of 9 over 25. Giving us 3/5 because it's in the second quadrant, making it -3/5. The correct answer is B. Moving on to question 21. This question tests your ability to find the fundamental parameters of an arithmetic sequence. We are given a sequence where the second term, a sub 2, equals 1, and the fourth term, a sub 4, equals 5. We need to find the first term, a sub 1, and the common difference d. Let's use the property of arithmetic sequence. The difference between the fourth term and the second term is exactly 2 times the common difference. So, a sub 4 means a sub 2 equals 2 times d. Plugging in the numbers, 5 means 1 equals 4, so 2 times d equals 4. This means our common difference d is exactly 2. The correct answer is A. Question 22. The focus here is understanding the fundamental properties of inequalities. We need to evaluate the statements about 3 real numbers, A, B, and C. Let's look at option B. It states that if A is bigger than B, then A plus C is greater than B plus C. In mathematics, adding the same real number C to both sides of an inequality always preserves the direction of the inequality sign. Therefore, option B is correct. Let's move to question 23. This problem tests your knowledge of the monotonic properties of functions. Y equals a to the power of x, where a is greater than 0 and a is not equal to 1. Let's check option C, which claims the function is always increasing over its domain. Here is our error analysis. A function is always increasing if the base a is strictly greater than 1. However, if the base a is a fraction between 0 and 1, the function is actually a decreasing function. Because this statement assumes it is always increasing without checking the base, it is the incorrect statement. So the correct answer is C. Question 24. The focus of this question is applying the double angle formula for sine. We are given that sine of alpha equals 3/5 and angle alpha belongs to the first quadrant. In the first quadrant, all trigonometric functions are positive. We can easily find that cosine alpha is 4/5. The question asks for sine of 2 alpha. We must use the double angle formula. Sine of 2 alpha equals 2 times sine of alpha times cosine of alpha. Plugging in our fractions, we get 2 times 3/5 times 4/5, which is 25. So the result is 25 over 25. The correct answer is B. Now for question 25. This question tests your ability to solve a system of linear equations to find an intersection point. We need to find the intersection of line 1 and line 2. Let's write them with constants on the right. 3x means y equals -8, and x plus 2y equals 9. To eliminate y, let's multiply the first equation by 2, giving us 6x means 2y equals -13. Now add this to the second equation. The y terms cancel out perfectly, and we get 7x equals -7, mean x equals -1. Substitute x back into the second equation. -1 plus 2y equals 9, so 2y equals 10, and y equals 5. The intersection is -1, 5. The correct answer is D. Question 26. The focus here is understanding the standard equation and focal properties of a hyperbola. We are given the equation x squared over 16(4) means y squared over 16 equals 1. From this standard form, we can identify that as a squared equals 64 and b squared equals 16. To find the focal distance, we need to calculate c. For a hyperbola, the formula is c equals the square root of a squared plus b squared. That gives us the square root of 16(4) plus 16, which is the square root of 80. This simplifies to 4 times the square root of 5. The correct answer is A. Moving on to question 27. This problem is a classic test of your ability to analyze the monotonic properties of functions. Option D is a power function, y equals x to the power of 2/3. The rule here is simple, because the exponent 2/3 is a positive number. This function is strictly increasing for all positive values of x. Since the base 2.1 is strictly greater than the base 1.2, the function value must also be greater. Therefore, 2.1 to the power of 2/3 is indeed greater. Option D correct. Question 28. The focus here is writing the standard equation of a cycle, giving its center and radius. We have a center at -3, 2, and a radius of 4. Let's recall the standard formula. X means h squared plus y means k squared equals r squared, where h and k are the center coordinates. Plugging in our values, we get x means -3, which turns into x plus 3 squared, y means 2 squared. Finally, the radius squared is 4 squared, which is 16. The correct answer is D. Question 29. This question tests your mastery of logarithmic properties. Let's examine option B. The proper change of base formula states that natural log of b over natural log of a. Option B incorrectly writes it upside down. The correct answer is B. Let's look at question 13. This question tests your basic knowledge of the properties of the sine function. The sine function is a classic odd function, which means sine of negative x equals negative sine of x. It has rotational symmetry about the orange. Therefore, calling it as an even function is totally incorrect, so the correct answer is C.